Concepts, constructs, and variables. Although research can be exploratory, descriptive, or explanatory, most scientific research tends to be of the explanatory type, that they search for potential explanations of observed natural or social phenomena. Explanations require the development of concepts, or generalizable properties or characteristics associated with objects, events, or people. Concepts may also have progressive levels of abstraction. Some concepts, such as a person's weight, are precise and objective, while other concepts, such as a person's personality, may be more abstract and difficult to visualize. A construct is an abstract concept that is more specifically chosen or created to explain a given phenomena. A construct may be a simple concept, such as a person's weight, or a combination of a set of related concepts, such as a person's communication skill, which may consist of several underlying concepts such as a person's vocabulary, syntax, and spelling. The former instance, weight, is an example of a unidimensional construct, while the latter, communication skill, is an example of a multidimensional construct. That is, it consists of multiple underlying constructs. Constructs used for scientific research, however, must have precise and clear definitions that others can use to understand exactly what it means and what it does not mean. Scientific research requires operational definitions that define constructs in terms of how they will be empirically measured. For instance, the operational definition of a construct such as temperature must specify whether we plan to measure temperature in Celsius, Fahrenheit, or Kelvin. A construct such as income should be defined in terms of whether we are interested in monthly or annual income, before tax or after tax income, and personal or family income. Constructs such as learning, personality, and intelligence can be quite hard to define operationally. A term frequently associated with and sometimes used interchangeably with a construct is a variable. In scientific research, a variable is a measurable representation of an abstract construct. As abstract entities, constructs are not directly measurable, and hence we look for proxy measures called variables. For instance, a person's intelligence is often measured as his or her IQ, intelligence quotient score, which is an index generated from an analytical and pattern matching test administered to people. In this case, intelligence is the construct, and IQ score is the variable that measures the intelligence construct. Whether IQ scores truly measure one's intelligence is anyone's guess, and depending on whether how well it measures intelligence, the IQ score may be a good or poor measure of the intelligence construct. As shown in the figure, scientific research proceeds along two planes, a theoretical plane and an empirical plane. Constructs are conceptualized at the theoretical, abstract plane, while variables are operationalized and measured at the empirical, observational plane. Thinking like a researcher implies the ability to move back and forth between and across these two planes. Depending on their intended use, variables may be classified as independent, dependent, moderating, mediating, or control variables. Variables that explain other variables are called independent variables. Those that are explained by other variables are dependent variables. Those that are explained by independent variables while also explaining dependent variables are mediating variables or intermediate variables. And those that influence the relationship between independent and dependent variables are called moderating variables. For example, if we state that higher intelligence causes improved learning among students, then intelligence is the independent variable and learning is the dependent variable. There may be other extraneous variables that are not pertinent to explaining a given dependent variable. They may be, but may have some impact on the dependent variable. These variables must be controlled for in a scientific study and are called control variables. To understand the differences between these different variable types, consider the example shown on this page. If we believe that intelligence influences or explains students' academic achievement, then a measure of intelligence such as IQ score is an independent variable, while a measure of academic success such as grade point average is a dependent variable. If we believe that the effect of intelligence and academic achievement also depends on the effort invested by the student, then effort becomes a moderating variable. One may also view effort as an independent variable and intelligence as a moderating variable. If academic achievement is viewed as an intermediate step to higher earning potential, then earning potential becomes the dependent variable for the independent variable academic achievement. And academic achievement becomes a mediating variable in the relationship between intelligence and earning potential. Hence, variables are defined as independent, dependent, moderating, or mediating, depending on their nature of association with each other.